Hey guys, Mrs. Stans here. So we're on lesson 8 in our statistics unit, and today we're going to be looking at how to make your calculator do a scatter plot and even write the equation for the line of best fit. So you can see that the title of the unit is linear regression on the calculator. So my objective says that we're going to use a calculator to create a linear regression, which really is a linear scatter plot. Okay, and when we see the words linear regression, they're really meaning find the line of best fit. Do a scatter plot, find the line of best fit. So this is a day that you absolutely need your calculator. To be honest with you, I would never do it by hand like what we did in lesson 7. I wanted to remind you of how to plot points and how we actually find the equation for a line by using the slope and the y-intercept and so on, but I am going to show you how to do it on your calculator. I did post something about quick notes on how to use your calculator. Of course, you could always go back and watch every video that I've done in this unit, and I show you exactly how to do it, show you what buttons to push, so you could always re-watch a video, and of course I'm going to show you step by step in today's lesson. After we take our notes, of course you're going to do the problem set. So it says that we did do it by hand last unit. It is called bivariate data. Bivariate, bi meaning two. There are two lists of data. You could see even down here in exercise 1 that there's the x values and the y values, and really what we're going to do is enter the x values into our L1 on our calculator and the y values into L2. And that's really what it's telling you to do for the do now. So if you could just enter that information in, and then we'll proceed. So my information's entered in L1 and L2. Remember, you can pause the video anytime you need to. And we can see that this is the same exact situation as lesson 7, that it's a survey of 10 low and high temperatures. So we actually already did this exact problem by hand yesterday, and I'm going to show you how to do it on a calculator, and we're going to compare and contrast what it looked like by hand versus what it looks like on the computer. So we have it in our L1 and L2, and then we're going to be creating a scatter plot. So let's write down some notes first. Remember, when we entered this stuff into our L1 and L2, the way that we did it was by first hitting Stat and then Edit. And that's how we get to our L1 and L2. But if I actually want to graph this on the graphing calculator, I have to go to my stat plot. Remember, on your calculator, your stat plot is right above the y equals, which means it's a second function feature. So to get to stat plot, you have to remember it's second and then y equals. We like to use the first plot, might as well. So if I hit enter there, you have to make sure it's turned on, and you probably actually have the scatter plot selected. The box and whisker selected, because that was the last thing that we did. So remember, to scroll through the type, you click your right or left arrow and get to this first one, which is a scatter plot. You can see that the points are scattered, and make sure that's highlighted. You can see that the X list says that we're using L1, the Y list says that we're using L2. I just leave the mark as is. And then if I actually want to see this graphed, remember, we don't just hit graph. I like to go to zoom. So far there have been 2 zoom features that we've used this year. We use zoom standard when we're doing typical algebraic graphs like linear equations, quadratic equations, exponential, things like that. And we go to zoom stat, which is number 9, when we're doing statistical plots. So if you can hit enter on number 9, you can see the scatter plot. So let's just go back to these notes here. So to actually graph, we do stat plot, and then we do zoom stat. Up here, this was to enter data. So to enter data, stat, edit, and put it in L1, L2. To graph it, get to your stat plot, which remember is a second function y equals, and then move to zoom stat, which really is number 9. And if we look at that graph, it actually looks like what we did in lesson 7. Let's take a look. So here's the graph I did with you in lesson 7, and here's the one that we just did in lesson 8. They look so similar to me. Now the scale, when we did it by hand, may be a little different than the scale that the calculator is using, and that's why maybe the one by hand tends to look a little steeper than the one on the graphing calculator. But if you take a look at the points that I did in red, they really do match what's over here on the graphing calculator. You can see that it is identical. It really is. I just don't have a line of best fit on my calculator. It's just a scatter plot. Remember, we did the line of best fit by hand, and we got this y equals 1.125x plus 20.75. So let's learn how to do that on the calculator. So on the calculator, we're still in the statistics unit, so it makes sense to hit the stat button. When we did our line of best fit by hand, there were some calculations we had to do. So it makes sense to move over to calc. Now remember I said that this is called a linear regression. You could even see it right in the title of the unit. And take a look at number 4 here on the calculator, linreg. This is an abbreviation for linear regression. Remember when we did our line of best fit yesterday, or 2 days ago, whenever it was in the form of y equals mx plus b. Look what it says in the parentheses here on the calculator, ax plus b. They're telling you what the form of the equation is going to be. So instead of an m, they're using an a, but it's a linear equation. So let's just write down what we did in order to get the line of best fit. So for the line of best fit, let's remind ourselves it's called a linear regression. I'm just doing all my notes in the margin here. We had to push stat, then we moved over to calc, then we moved down to what said linreg, linear regression. Let's go back. Let's go down to number 4. And let me just clear for a second. I just want you to see a nice clean screen. So if we go down to number 4, I get this. You will have a couple of other things and it'll say calculate. So you're going to move down to calculate and hit enter. And you can see that it tells you your equation is in the form of y equals ax plus b. They tell you what a is and they tell you what b is. So on a test, that's not a multiple choice question, you have to show some sort of work. So you have to copy this information down and then substitute the a and the b in the proper places. So for the equation for the line of best fit, right down here, I'm going to write down what I see on my calculator screen. Y equals ax plus b. A was, now let's just read these directions for a second. It says round the slope to the nearest hundredth and the y-intercept to the nearest integer. So A is the slope to the nearest hundredth would be 1.16. b is the y-intercept. It says to the nearest integer, so that would be about 19. And now I fill in the numbers, and my answer is y equals 1.16x plus 19. This is my equation for the line of best fit that I got from my calculator. Over here it's asking us to write down what we got in lesson 7. So remember, it was y equals 1.125x plus 20.75. And take a look at these two equations. They're not identical, and we talked about in lesson 7 that when you draw a line of best fit, your line of best fit will definitely be different than someone else's line of best fit, but both of them are probably acceptable as long as you follow the rule of drawing the line that follows the path of the points, so that about half the points are above the line and half the points are below the line. Well, the calculator is a little more accurate than we are. So I would say that the calculator's line of best fit is probably better than the one from lesson 7 that we did, but holy cow, look how close they are. I mean, we actually did do a very good job. I want to go back to the calculator and show you how you can put that line on the scatter plot. Now, since we already did all the statistics, hit zoom stat, if I want to see that scatter plot again, right now is when I can just hit the graph button, because it's already programmed in to be in a statistics mode. But if I want to see the line going through that, go to your y equals, clear out whatever you have there, and type in what the calculator found. So we have y equals 1.16x plus 19. From here, again, we already have our window set up exactly how we want it, so just hit graph. Take a look. The line follows the path of the points. There's about half the amount of points above the line as below the line. If you wanted to compare it to the line that I drew, it really is pretty close. What I could say is that maybe the bottom left of my line is a little higher than what the calculator did, because I could see the calculator made it go through that first point, where my line is a little above that first point. So that's the slight difference in my equation versus my line versus the calculator's line. But really, really so close. I would actually always use the calculator and not do it by hand. I'm really encouraging you to do such a thing. So questions like C appear on the Regents Exam often, where they want you to say what the certain numbers represent in a given equation. So here they're asking to explain what the y-intercept of this model represents in terms of low and high temperatures that are being modeled. So really, what does the 19 mean in the context of the situation? Those are words that we see often, in the context of the situation. So the y-intercept is 19. And really what that means is it's the point 0, 19. I still haven't explained what it means in the context of the situation, but if you understand that it's the point 0, 19, when you take a look at the graph, 0, 19 would be on the y-axis. 0 is the low temperature because it's the x value, and 19 is the high temperature because it's the y value. So what does the y-intercept mean? It actually means if there is a low temperature of 0, we would expect, it's not guaranteed, it's like a prediction, we would expect a high temperature of 19. So remember, a line of best fit helps us make predictions. Okay, life is not perfect. Life doesn't have things land in a straight line, but some situations in life can be modeled by straight lines. We'll see in future lessons that some things in life aren't modeled by straight lines, that things like grow exponentially, therefore we use an exponential function, and so on. Let's do D. How would you interpret the slope of this model in terms of how the low and high temperature changes with respect to each other? So since the slope is equal to change in y over change in x, and we see that the slope of our equation is 1.16 over 1, right? We can write it like this. It means that the y's are changing by 1.16 as the x's are changing by 1. So how would you interpret the slope in terms of how the low and high temperatures change with respect to each other? I would say something like for every 1 degree of increase in the low temperature, we expect a 1.16 increase in the high temperature. So let's practice entering information into our calculator and getting a line of best fit for another problem. So generally, the fuel efficiency of a car changes with the weight of the car. A survey of some cars with their weights and gas mileage is shown below. So we have the weight and the mileage. Find the equation for the line of best fit using your calculator. So remember, that's a LinReg, a linear regression. Round both coefficients to the nearest tenth. List what the variables x and y represent in this problem. So I'm going to make this x and this y. Therefore, this is our L1 and this is our L2. So let's enter that into our calculator. Before I enter, I just want to remind you, remember we hit Stat, Edit. I just cleared everything, and that's where you enter it. So I have everything entered into my L1 and L2. Next, remember, you hit Stat. It's a calculation, so move over to Calc. Linear regressions, number 4. Go down to Calculate and hit Enter, and write down the information. Remember, we're rounding to the nearest tenth. So it's in the form of y equals ax plus b. A is about negative 8.1, while B is 68.1. We write it as an equation, y equals negative 8.1 x plus 68.1. It also asks us to list what variables x and y represent in the situation. So we let x equal the weight of a car, weight in pounds, in thousands of pounds, and y represented the mileage per gallon. It says to create a graph of the scatter plot for this data, and would you consider the correlation between weight and mileage to be positive or negative, and to explain. So we go to, we got to plot it, so stat plot. I'm going to go to my first plot. It's on scatter plot. I'm just going to go to zoom 9 because it says zoom stat, and hit enter. See that random line I have? I hope you're realizing that we have something in our y equals that went with another graph. So let's go to our y equals and delete that. And then I'm going to hit graph again. This is the scatter plot for this second exercise that we did about weight of cars and mileage in miles per gallon. And here's the scatter plot. If I wanted to do like a little sketch of it, I would say it looks like the points are going this way. Okay, this is definitely not a perfect graph, but it's going down to the right. So when it asks is it a positive or a negative correlation, since as x is increasing, y is decreasing, it looks like a negative slope, therefore this is a negative correlation. And I just want to remind you back from yesterday's lesson, we talked about the correlations on this page, right? We have positive correlations, some are strong, some are weak. We have a no correlation, which means I can't draw a line anywhere. And then we have some negative correlations. Again, the closer the points are to the line, the stronger the correlation is. So we just have to be careful of, I guess, some vocabulary in this problem. They use these words often on Regents exams. Which parameter? They mean which number in the equation, a negative 8.1 or the 68.1. Which parameter of the linear model? They call this a linear model because it's what's modeling the situation. It might not be perfect. Might not be a perfect model, doesn't hit every point when I draw that line through it, but it models the situation well. So which parameter of the linear model predicts whether the correlation is positive or negative? So by looking at the graph and it going downward, we were able to say it was a negative correlation. We're able to say as x increases, I'm back to b for a second, as x increases, y decreases. So which parameter shows this? Well, actually it's the slope. The slope of negative 8.1 shows that it's a negative correlation. And there's a few things that we could say. Since it's negative, it does mean that it's going in a downward path. Since it's negative, it does mean that as x increases, y decreases. Because think about it, remember slope is change in y over change in x. Therefore, I can write it as negative 8.1 over 1. So here my x is positive. As x is increasing by 1, y is decreasing by negative 8.1. Let's do D. So this really is just using our calculator, but being very careful with the numbers that they're giving us. So if a car had a weight of 4,300 pounds, now remember what the weight is. Remember, the weight is already in hundreds of thousands of pounds, I mean. So when we see 43,000 pounds, this means to use x equals 4.3. Right? If I took 4.3 and multiplied it by 1,000, I'd get 4,300 pounds. So this is the x we have to use in the equation that we found. So y equals negative 8.1. I'll substitute 4.3 into in for x plus the 68.1. And then I would do this straight on the calculator. I'm going to my home screen and just doing negative 8.1, using parentheses to multiply by 4.3, and then adding on 68.1. And I get 33.27. Let's read this. It says round to the nearest integer and to use appropriate units, and make sure the answer makes sense. So I get about 33 miles per gallon. And does it make sense? Take a look at the table, even the chart. 4.3. If I look for something in my table around 4.3, I could see what the mileage turned out to be. So I guess 33 could make sense. Okay, it seems like maybe it's a little bit high, but you could even take a look at our scatter plot. You can see that maybe it's not a perfectly straight line. So maybe our linear equation isn't so perfect, but you know what? It's a good enough estimate for now. If we do part E, we want to purchase a car that got 40 miles to a gallon. Oh, so that's my Y value. So using the equation, in place of Y, I'll put the 40. And I'm trying to solve for X now. It does say solve it algebraically, so subtract 68.1 from both sides. 40 minus 68.1, a negative 28.1. Divide both sides by negative 8.1. I'm going to write down the whole thing. 3.4691 35802. Now I'm going to go read. So remember, first of all, X is in thousands of pounds. So if I multiply this number by 1,000 to change it to pounds, I get 1, 2. So I get 3,469 point such and such. But do you see how it says round to the nearest 100 pounds? 100. Here's the hundreds place. This 6 rounds the 4 up. So when I round to the nearest 100 pounds, I get 3,500 pounds. And that's that. So good luck on your homework. Send me any questions, and hope to talk to you soon. See you. Bye.